Welcome to doassignment-ca. Here is the problem. A data set records the average daily temperature in degrees Fahrenheit and the number of ice cream sales for 6 consecutive days. Day 1, 62 degrees, 18 sales. Day 2, 68 degrees, 35 sales. Day 3, 75 degrees, 52 sales. Day 4, 71 degrees, 45 sales. Day 5, 79 degrees, 68 sales. Day 6, 85 degrees, 81 sales. Part A. We start by writing each observation as an ordered pair, with temperature as x and sales as y. Our 6 points are 62, 18, 68, 35, 75, 52, 71, 45, 79, 68, and 85, 81. Because sales go up whenever temperature goes up, we already expect a positive linear trend. Here's the scatter plot. Temperature runs along the horizontal axis from 58 to 92 degrees, and sales run along the vertical axis from 0 to 95. The 6 data points rise steadily from left to right, which confirms the positive linear relationship we noticed. To draw a line of best fit by hand, we pick 2 points that represent the overall trend, points that the line actually passes through. We choose 62, 18 and 85, 81 because they span the full range and sit right on the trend line. We apply the slope formula, y2 minus y1 over x2 minus x1. That gives 81 minus 18 over 85 minus 62, which equals 63 over 23, or approximately 2.74. This means sales increase by about 2.74 for every 1 degree rise in temperature. We plug our slope and the point 62, 18 into point slope form. Distributing 2.74 gives 2.74x minus 169.88. Adding 18 to both sides gives y equals 2.74x minus 151.88, which we round to y equals 2.74x minus 152. That is our line of best fit in slope-intercept form. Now we overlay the line of best fit on the scatter plot. The line y equals 2.74, x minus 152 runs right through the middle of the data cloud, with some points slightly above and some slightly below, which is exactly what we want from a good line of best fit. For part C, we substitute 90 for x. 2.74 times 90 is 246.6. Subtracting 152 gives 94.6, which rounds to about 95 sales. So at 90 degrees Fahrenheit, our model predicts roughly 95 ice cream sales. For part D, we check whether 90 degrees falls inside our data range. Our temperatures go from 62 to 85 degrees, so 90 is just outside the range. When we predict outside the data, it is called extrapolation, and it is less reliable than predicting inside the range, which is called interpolation. Our prediction of about 95 sales is still reasonable because 90 degrees is only 5 degrees beyond the last observation, and the trend looks very linear. But we should acknowledge that the linear pattern might not hold perfectly at higher temperatures, so there is some uncertainty in the answer. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.